Let's now look at how to use multi-axis operations with flow. As before, select the required surfaces on top of the mouse and change their vector directions accordingly. In the Multi-Axis tab, check the Use Multi-Axis button. Tilt parameters can now be defined to give the tool the option to tilt around the Z-axis. Forward tilt is defined in two ways. A lead angle is where the tool is tilted towards the direction of cut. Conversely, a lag angle is when the tool is tilted away from the direction of cut. Sideways tilt will tilt the tool around the direction of cut. Entering a minimum tilt will always mean the tool is tilted, whilst maximum tilt defines the limit of the tool either side of vertical. Simulating this, we notice that although the tool has full freedom to tilt, the ball end mill is cutting the part normal to the surface with the tip of the tool for an entirety of the cut. As the tip of the tool has almost zero surface speed, the tool will leave a dull and poor quality surface finish. To fix this, let's add a side tilt of 25 degrees and limit the toolpath to 45 degrees either side of the vertical. Simulating again, the toolpath shows a smooth, simultaneous multi-axis toolpath, with the tool cutting on its side ensuring a smooth and even surface quality finish. The axis can also be displayed to show how the tool will be orientated at each point while cutting is denoted by a yellow line. Let's also quickly have a look at how the toolpath points are distributed. Clicking the Show Points button, we can see an even distribution. Let's now compare that to the parallel strategy, where although the cutter paths look suitable, the point distributions are not nearly as evenly spaced. Having evenly distributed points means a smoother machine axis motion and leads ultimately to a better surface finish. Thanks for watching, and from me, cheers.